Divya, wait for one minute. Let Rohini go.
Oh, already it is in YouTube. Already it is in YouTube.
Yeah, it is started.
Okay, okay.
Hello, hello. I'm
So it has started streaming. So let's start, I think.
Yeah.
Yeah. We will share that PPT also. Maybe if Rohini Madam is not doing, so other can propose. Okay. Good afternoon to all. Welcome to the last academic session, the 20th lecture of the weekly online lecture series on radar meteorology, jointly organized by South Asian Meteorological Organization and Advanced Center for Atmospheric Radar Research, Cochin University of Science and Technology. As we are towards the end of the academic sessions, and today we have a prominent figure with us. He is well known in India, though from Bangladesh. He is well known among Indian meteorology community. And without much delay, I welcome all, and I invite Professor Someshwar sir to propose the formal welcome address.
Okay, thank you, Dr. Avilas. Am I audible clearly?
Yes, sir. Yes.
Great. So, ABM Professor Ajit Tyagi, the President of SAMA. And today we are glad to have Dr. Samrendra Karmakar. He is the former director of the Bangladesh Meteorological Department as well as the SMRC, the South Asian SARC Meteorological Research Center at Bangladesh. And also presently he is the member of the advisory panel of SAMA. So welcome, sir. And also Dr. Avilas, he is the director of the ACARR, that is Advanced Center for Atmospheric Radar Research at Cochin University of Science and Technology. Also the host of this lecture series on radar meteorology. Today's distinguished speaker, Dr. Mohan Kumar Das, as already said, he is well known, among us. Also, he has been working for a long time on the applications of radar, Doppler weather radar on meteorology, especially the data assimilation of Doppler weather radar data in the NWP models, together with the former assistant director of VMD, Mr. Sujit Dev Sarma. In fact, we have been working together for many years, and we have also co-authored or shared many papers together in research publication journals. Today, he's going to talk about his experience on the archival of the radar data, utilization of radar data. So we are glad to have him here. Then other members of the organizing committee, of course, Dr. Mohan Kumar himself is an active member of the organizing committee, also the joint secretary of SAMA from Bangladesh. Then we have got Dr. Swagat Paira, the member of the organizing committee, also the treasurer of SAMA. And from Bangladesh, we have got Shah Alam from BMD. We also have got Dr. Kyal Win Oh, the member of the advisory panel from Myanmar. So we have got a distinguished presence of the many members of the advisory panel of the lecture series. Welcome to all of you on behalf of the ACARR, CUSAT, and SAMA. I don't have to tell much about the lecture series because Dr. Mohan is already well known. He himself is a member of the organizing committee, and also everybody knows about this lecture series background. So I don't have to tell it. Today, as already said by Dr. Avilas, that today is the 20th lecture of the 20 weeks lecture series on radar meteorology. And after that, we'll have one more talk on industrial applications or from the expert from the industries who are the manufacturers of the radar. Then that will be followed by the hopefully the final examination test on 16th, and then afterwards there will be a valedictory function. So welcome all of you. As usual, all of you can write your questions in the question and answer box, and Dr. Mohan will answer those questions at the end of his talk. So already we are late by about 15 minutes, so I will not take much time, and have a nice session. Over to you, Dr. Avilas.
Thank you very much, sir. Now I invite our distinguished President of SAMA ABM, Professor Ajit Tyagi sir, to propose the presidential address.
Thank you, Abhilash. Am I audible?
Yes, sir. Yes.
Yes.
Okay. Very good afternoon, and I join Abhilash and Somesh in welcoming all of you. This is the last but equally important lecture. In fact, it culminates from the basics to various applications, and finally, practicing meteorologists who have used the radar data both in research and also in application. So it's a thank you, Mohan, for agreeing to deliver this lecture. We have eminent colleagues here today is attending the lecture. Dr. Kumar is there, Dr. Kalim, who is there, Shalam from Bangladesh, and also all our organizing committee members are there today in full strength. So this is really good. And as mentioned that this is the last lecture, but a well designed and implemented training program. And all 20 lectures have been of great value, each one complete in many respects. And over a period of time, we build up this subject very well. And all these lectures are available also on YouTube. So I'm sure the students will benefit for a long time to come from these series of lectures. So once again, thank you for joining this lecture series. And I'm personally thankful to all those resource people who have delivered the talks in this series of lecture, and also to the organizing committee from ACARR, CUSAT, who have done a good job. I must say, Shrikala and Rakesh heavily supported Abhilash in organizing this series of lecture. So it shows the strength of the SAMA, that yes, we had conducted these lecture series from also to the organizing committee from ACARR. Okay, so with this opening remarks, I once again welcome and make full use of these lectures, today's lecture. Over to you, Abhilash.
Thank you very much, sir. Today's lecture, weather radar and climate long-term radar data set, their preservations and analysis, to be delivered by Dr. Mohan Das. He is the director of National Atmospheric and Maritime Institute in Bangladesh, and he is a well-known figure among us. And I request Dr. Rohini to introduce today's speaker to the audience.
Thank you, Dr. Abhilash. Yes, it is indeed a great pleasure to introduce Dr. Mohan Kumar Das, one of our ECT members also. So, Dr. Mohan Kumar Das is the Executive Director of the National Oceanographic and Maritime Institute in Bangladesh, that is NOAMI. With an extensive career in hydrometeorology, he has held roles in the Bangladesh Meteorological Department, the SARC Meteorological Research Center, the Institute of Water and Flood Management at Butte, and the Regional Integrated Multi-Hazard Early Warning System. He is also an adjunct faculty member in the Department of Meteorology at the University of Dhaka and the Department of Oceanography and Hydrography at Bangabandhu Sheikh Mujibur Rahman Maritime University. Dr. Das earned his PhD for his research on Doppler weather radar, data assimilation, and extreme weather prediction. His research has garnered recognition, including the UNESCO /IOC-ODC Ocean Science Best Trainee Award and the Best Presenter Award, professional category at the International Conference on Climate Change in 2022. He serves as a member of the Executive Coordination Team, that is ECT member, and is also the Joint Secretary of the SAMA, actively contributing to the professional growth of the field. He has published over 50 peer-reviewed articles on climate extremes, nor'westers, tornadoes, and cyclones, and he regularly writes for popular print media to raise public awareness of climate science. Dr. Das has represented Bangladesh in numerous international conferences and has conducted training programs across Asia, Europe, and North America. As associate editor of the Journal of NOAMI, published since 1984, Dr. Das oversees research on oceanic and coastal systems as well as blue economy themes. He is a member of several professional organizations, including the Bangladesh Physical Society, BCS, the International Association for Urban Climate, and the Oceania Geosciences Society, that is AOGS. Dr. Das has also contributed to various national and international projects, including the High-End Climate Impact and Extremes project, that is the HELIX, seasonal and sub-seasonal projects of UN ESCAP, and the implementation of the flash flood guidance system in South Asia. His work has been funded by the US Agency for International Development Office of Foreign Disaster Assistance through the World Meteorological Organization, as well as through the operation and maintenance logistics of the Agro-Meteorological Information Systems Development Project funded by the World Bank. So over to you, Abhilash, and welcome, Dr. Das.
Thank you. Thank you very much, Rovini, for the nice introduction. And now I request Dr. Mohan to deliver his talk.
Thank you. Thank you so much. I'm very grateful to all of you. Welcome everyone. So today's lecture actually tried to cover some aspects, especially how we can use weather radar for long-term purpose, especially for the climate application. Is it possible, or what are the real limitations? What is the present scenario over the globe, not only the aspect of the South Asia itself? So before I start my presentation, I am very much grateful for one World Meteorological Organization study done by Global Climate Observation System, that is well known as the GCOS. And this is weather radar data requirements for the climate monitoring, and some others relevant studies what already been done. But the reality is that the overall climate application by using radar data is very, very limited. So in my lecture, I tried to cover some requirements of the radar data for climate analysis, assessment of the existing archives, and what are the actually real limitations of archives, and guidance to organize a standard format. Of course, radar data standard format, unique format is very much required for the global aspects, and storage issues, guidance for the historical data, what already been data is stored, or if not stored, how we can study it from today itself. Radar data used in climate analysis, some study already been done especially in the developed country, and some key recommendations, and also a small survey initiative which can be conducted by using the SAMA platform. I think it would be much more helpful after SARC Meteorology Research Center coordinated study is almost stopped. But as you know, for the weather system, it is very much needed. So many of you knew that exactly radar application started for weather after 1950s. So what is the beauty of radar is that it is very much high resolution and very effective, and in terms of the horizontal resolution, it is also very time and space, both resolution is very much high. So in the figure, we can see that what is the present global radar coverage over the globe. So we can see many areas of the globe is still out of the coverage, especially in the African regions and high mountain regions. Of course, you can say even the Southern American region itself. The good thing is that in the Southern Asia, the radar coverage is mostly in a well coverage, especially all over the coastal regions. It is covered by the coastal regions of the India. It is covered by the radar system as well as the Bangladesh and Myanmar. Not very much. So the gap is there. Many of you knew that Nepal there is a radar, but in the Bhutan, Afghanistan, still we don't have that much of information regarding the radar, how it is there or not. But as of we know that there is no radar itself. And in the Australia, all the coastal boundary is covered by the radar, but in the many parts of the region is still now out of it. But Eastern Asia, there is also well coverage. So it seems that the populated regions of the world, somehow it is coverage by the radar. It is a good thing. So we can do, if we have the very good coverage of the climate long-term data through the radar, it can be utilized for climate studies, hydrological model, and coordinated other aspects as well. But what is the real challenges? The real challenges of the radar data is the storage issues, because when many institutes start to install radar observatories in their territory, but they are not concerned about the storage. It may be because of the monetary issue, maybe because of the maintenance issue, maybe some other issues as well. So one important initiative was taken in 2016 by the WMO and as I mentioned, GCOS, how we can take one global platform for the very important database of the radar and others as well. So for this purpose, they have started to take an initiative to for a survey over the almost WMO countries, member countries. But it is found that out of the all member countries, only 91 countries utilize radar for their daily decision making. Many of you knew that radar is mostly utilized for the nowcasting purpose and aviation purpose. It is very sensitive. If we properly able to utilize radar in nowcasting aspects, especially for the hail event, tornado event, heavy rainfall event, it means all sorts of meteorological convective system events. So you can precisely give the nowcasting. It means 3 to 6 hours interval information to the community, very precise time and location specific. So they can save their lives, livelihood, etc. But in the aviation, it is also important. And within that, when they conducted the survey with a very simple set of questions, like when they have started to launching their radar for their decision-making procedure. So it is found that most of the, it began actually from 1975. Some countries started after that also. So, and when they started to storage, is there any storage availability they are maintaining or not? So some respecting institute responses that yes, they are maintaining, but most of them are mentioned that not, they are not maintaining the data storage, for only they are using the radar for their decision making. And another, what are the other limitations? So all sorts of some questionnaire they have. So in the figure you can see that in such responses, very limited country are what is called involved. So mostly in the European countries and Northern American countries, Latin American countries, as well as the Australian, and in the Southern Asia, only 1 or 2 countries joined the survey. So it's really a gap. So I think that gap we can fulfill in by taking one initiative through the SAMA itself, as I mentioned in earlier. So what is the requirement for data for climate analysis? One is the extensive coverage. So like rain goes not cover all the location of a country, but if we able to install automatic weather station, so it can be cover mode. But if there is a good coverage of radar, it can be cover all the locations, even the data sparse regions as well. So, and challenges. Challenging is the more to the long-term data continuity. Like in our country, we have seen that after 90s, they have started install radar in many places of the Bangladesh, like Dhaka radar. It is well prominent one. I think Dr. Shamsud Das are already very familiar when he was in Bangladesh. He and Dr. Nazrul sir started one harmonized study for the South Asian regions. I will show one slide on that in some of my slides. So that is very important. But that time also we faced similar issues for other countries as well. Getting the data, storage of data, data availability, those things. And another thing is the homogenization and the harmonizations. It means some radar are manufactured by some different companies, like some are from the Germany, some are from the Japan, some are from the India, some are from the China, some are from the USA, like this. So they are using different kinds of software, different kinds of procedures for their data archival and others. So there should be one unique system, what is not there. And another issue is the data recovery. That what kind of issue is there? Like there is a lifetime of the all instrument, especially of the radar. So if it is 5 years, 10 years, after that, they started one new radar in their locations. Maybe first data software and other things are outdated. So they are not using those things in a proper way. So archival is a issue, and data harmonization is the issue. Data recovery also a issue, and like some specific regions using some specific system or algorithm for their database. But what would be the global data management system? That's also needed, because when someone started to do some bigger area study, so if some specific countries has some specific algorithm or a specific management system, it can be a difficult procedure to do data study for their specific regions as well. So requirement of data of radar data for climate analysis, usually levels of weather data. In that study, they harmonize all the things in a 5 procedure. One is called the level 0 and level 1, level 2, level 3, level 4. What exactly level 0 indicates? Level 0 indicates just the observation, what directly taken through the radar, that is the full resolutions as received as the sampling rate of the receiver, generally only available internal to the system. Especially equipment may be required to measure and record such data. Most of the time, they not archive those level 0 data. Level 1. Level 1 is the mainly the time series data. It is called in-phase and quadrature data. Produced and processed by the instrument signal processor. So it has limited recording. Level 2, that is very much important. I would like to explain a little bit more about the level 2. It is the derived variables, mostly instantaneous moments like reflectivity. Already many of we are already been familiar with all the radar products. The radial velocity, reflective and radar velocity, these two components are very much important. And in addition, differential reflectivity at the full resolution after aggregation and filtering, organized in polar coordinates by rays or range, beams, and quantiles, also known as the sweep and the volume scan data. That is important. And another others levels data is called level 3 data. That is the derived products that could be polar coordinate or the Cartesian coordinates, and it covers the vertical profile itself. Finally, that is called level 4 data. That is the high order products which may include data from multiple measurements. This includes product with composite multiple radars, mosaic radar. Nowadays, it is very popular. Like in our country, Bangladesh Air Force, they use 2-3 radars in 3 different locations, like one in the coastal region, one in the central part of Bangladesh, another in the northern part of Bangladesh. So they can make some, they usually make some mosaic of radars. So all the hydrometeor, reflectivity or rain date, we can see at a glance. So it can mostly it can be very useful for the numerical weather prediction itself. So what are the key parameters we can archive for the climate data analysis? One is the horizontal reflectivity, radial velocity, spectrum void, differential reflectivity, correlation coefficient, differential phase. Except horizontal reflectivity and differential phase, others 4 parameters only be available through the Doppler weather radar. So nowadays, this is also one important thing. What kinds of radar we are using? It is C-band or S-band or X-band, and others issues are there. So configuration is also important. So assessment of existing archives. After the questionnaire survey, it is found that we can see the radar data since 1975. How many countries started their radar data or radar for their countries? Like very few. 1975 to 1985, only 5 or 6 countries started radar or the archive. They started to archive their radar data for the long-term analysis. Like Hong Kong, one is the best example is the Hong Kong. After that, with the time it gradually increases. After 2005 and 2015, the increment is very good, like more than 40 countries. So out of 47, 45 countries started archiving their data, and that is the one important issues. So mainly the WMO established their task team in 2014. So they started with communication through the WMO member states, and the mainly National Meteorology and Hydrological Department. But in addition of the National Meteorology and Hydrological Department, there are some other organizations as well who are also using weather radar for their decision-making procedure. Like in our country, one example is the Bangladesh Air Force. And what are the documentation? Is there any systematic documentation is there or not? So it is also found that the right in the panel, radar archive available. So we found that Bureau of Meteorology from the Australia, they started to archive, but they have also some limitation with the past data. Royal Meteorological Institute of Belgium, they also archive their data quite in a proper way. Croatia, Meteo France, and German Met Department, Icelandic Meteorological Office, Norwegian Meteorological Institute, and from the Oman PSEA, and Institute of Meteorology and Water Management of Poland, a Swedish Meteorological and Hydrological Institute, that is well known as the SMHI, Meteo Swiss, Royal Netherlands Meteorological Institute, Turkish State Meteorological Service, Met Office, Royal Met Office, which is from UK, and NOAA. So all those countries, they started archiving their data in some procedures. Still, they are facing some limitation with their first data, but nowadays they are in a good procedure maintaining to archiving their data. But still, one organization data can be useful for the other organization. That is another question. Like and some data is not freely available for the researcher or community also. Sometimes it is not open source. And so, but it is good thing that within the globe we knew that these countries are well maintained their data. Maybe nowadays some other country also started these things, but or other country can be inspired to do these things. So one important example, like German Meteorological Institute, that is one of the DWD, they reprocessed since their data since 2001. And that survey I mentioned, 7 questions, they already been given to the organization or member state. And most of the countries use radar for the daily decision-making procedure. That is the hail event, tornado event, heavy rainfall event, these kinds of snow or others detection. So assessment of existing archives, there should be one data standard procedure like and there should be one designated data center for this. But most of the national department not able to maintain these kinds of procedures. And documentation, there is a limitation, and data portal, some are freely available. So there in this table, I would like to show from the Bureau of Meteorology. They archived 79 radar data in their system since 1988. But in the European countries, altogether 140 radars data they started to archive since 2012. And to use those data, they usually ask for the license. So the email is given there. Germany, 17 radars is there. When in Germany, maybe we knew that there is a their rain gauge is not cover whole of their country. Netherlands, they started two different time steps. Some are from the 1998, another from the 2008, only 2 radars. And New Zealand Met Service started with 9 radar since 2011. Norwegian Met Office with 9 radar 2010, and United States next generation radar now since 1991 within the 160 radars. So guidance, there in a nutshell, we should say there should be user interface assessment we should require, and there should be a general principle which mainly focus on the climatological data. So main limitation is the lack of defined storage. As I mentioned, most of the countries or institute, when they started installation radar, they started to operational their radar, but they're not given requirement of the storage. Even nowadays also, even recent some communication through the some national met department, we also personally knew that they started to launch new radar for their institute, for their country, but they ignored the storage things. So sometimes we personally inspire them to make storage facilities, but that is also issue, how long they can do it. And for the storage organization, there should be access performance things. There should be data sorted with type and time. And for this, we need to follow some standard procedure with those countries already been already started, like some 10 countries we have shown. Within this, Meteor France is one best example. And of course, there should be user interface should be there. So anyone from the within the research community or the decision maker or anyone can automatically get the data access. There a standard interface for this needed, and regional access is required. And for the data transfer, because of the data size may be varied, so how we can improve data transfer procedure? There should be one important protocol for that. So for this, like global communication system, I and WM meteorological member countries collect the synoptic data every 3 hourly. They pass their data through the GTS system. So these kinds of global radar portal should be there. So instantaneous radar data can be passed through the community, and there should be one global archive accordingly. So as there is a strong limitation regarding the storage organization, that is the access efficiency. So main is the access of the speed and data storage, what type and time, like if data is every 5 minutes interval or every 3 minutes interval. So what kind of time interval they should follow? It should be 5 minutes or 10 minutes. Then and what would be the data format? These kinds of things need to be in a systematic way. And data structure, if there is some the standard procedure is still there, and also WMO FM128, there is one coded system which is usually used in the numerical data procedure. So there's kinds of one standard format they can mention, but they can maintain. So it is required. And transition to database records to needed to improve through the organization requires significant effort for the transfer of the data. It would be the future needs from the institute to institute. And for the historical data, the important things, like when one country started their radar operation, like the 1990s or 2000. But after 10 years, maybe the install the new radar. And what are the status of the previous radar data? Most of the time, they not archive those things in a proper way, and format is already been outdated. So one important initiative is required for the inventory maintenance, and one unique data uniformity is required, and how we can rescue those past data. Exactly, an Australian Bureau of Meteorology started to rescue their past data. They found that some data is overlapping, like similar same data overlapping with one with another. So to manipulate to rescue those manipulated data is another challenge, and it is really required to preserve the metadata in a proper way. And that's why most of the time, and also WM also recommended to archive the level 2 data. there is some link is given for the digital preservation of the handbook, which can be helpful to the MET community. I think they have the lack of manpower or lack of expertise. So how in future they can do it with the help of the academician or researcher? That is a good, that is a burning question. And some readable documentation link is also given here for further initiative. So when we started to check the climate-related study literature or study already been done over the South Asian regions or other parts of the globe, we found there is almost no study done over the specifically in South Asia, or we can say Bangladesh, India, and adjacent regions. One important initiative was taken in 2012 onwards, which publication is published in 2015. That is specifically the one pre-monsoon season. Actually, the study is led by Professor Dr. Someshwar Das sir when he was in the CUSAT Meteorology Research Center. So a whole pre-monsoon season study is done with the one conventional Dhaka radar, and that's horizontal reflectivity converted as a rain rate, and this rain band and rain structure is also been studied for the whole seasons, and some specific events compare with the tropical rainfall measuring mission 2825 particle extended cloud particle extended data. And also there at that time there was a functional Cox's Bazar Doppler weather radar. Dhaka radar was not the Doppler one, but Cox's Bazar radar was the Doppler radar. And after the analyze all those observations by using the radar, after that it compared with the numerical model itself, and there is a composite characteristics is formulated after the study. Then what is the cloud top altitude through the TRMM or the model? Like propagation speed from the radar itself, and it compared with the model. So these kinds of results are well documented, and that is the maybe first and almost final study. After that, there is a not that much of harmonized and archive data not available. So it is a really gap. It is a, if I think SMRC was not exist that time, maybe that study was also not done. So this is really one tremendous milestone from the SARC Meteorology Research Center. After that, nothing, no that much documentation was available. As I mentioned, so if it can continue for the after 2010, it was the study of 2008. So you see, after that, we almost passed 15 years. So, but we are not capable to archive those data in a proper format. If it was there, we can maintain at least half of the climatology. Half of the climatology means WMO always mention or give the priority that to do a study at least needed 30 years database. So if really it was there, so we can by this time we can maintain 15 years of database, but it was not there. Even we don't have the 1 year database itself. And regarding the seed in 2013 and 2019, both tornado events occur in month of March. One is the 22nd March and another 31st March, 2013 and 2019. Luckily, Bangladesh event that is called Brahmanbaria tornado, Agartala radar was there. So through the radar, almost the same time, maybe there is a some minutes gap is there. So within the radar, we can see the vertical extent of the cloud during the tornado, and we can see the horizontal expand of the echo, etc. But the event which occurred over the Nepal, and maybe historically that is the first tornado event which is recorded over the Nepal, and many studies already been published in many prestigious journal. So see there we cannot see any reflectivity or any other information because there was no radar coverage within the Parsha village of the on the village which is over within the Parsha districts. So those kinds of harmonized regional coordination and cooperation is very much needed. If Agartala radar data is available, but only you can see the image. If data is available, you can use this data through the data simulation. But maybe due to archival or other procedures, we are not able to collect the data that time. But nowadays, Nepal installed one radar for their regions, but I'm still not sure they are archiving their data or not. If not, I think SAMA can inspire the all South Asian MET communities how they can install or they can store their database in a proper format and proper way. In future, for the next generation, it will be a resource for the climate study. And you see from the in Bangladesh, in terms of the radar coverage, it was the very rich once upon a time. Nowadays, most of the radar are not non-functional, but there is some new radar is now installing. One radar already been installed in Gazipur. It is a central, almost central, not central part of Bangladesh. So now it is in operational phase. One meteorological representative is there. We always request him also and the community authority to archive the data in a proper way. Hopefully, they will do it in future. So you see, that is the one important study. As in previously sir mentioned, that is one important study for my PhD itself also. And Sudhit Kumar Devshan Masal also support that time very much. So in the reflectivity, through the Kepupar radar, it is a coastal radar within the coverage of the 200 kilometer or within. So one strong radar hydrometeor echo is there. And another event, 19th May 2011, we can see another convective system over the regions. And another, all in the month of May, after 10 days, about 2 days later, 21st May. So what actually we did, we assimilate all those radar data into the numerical model. So in the satellite, you can see the two intense cloud convective cell within the Bangladesh. One is very closer to the our northwestern part, another is the northeastern part. And within the time, they merged together and it has started a very strong convection over the region. It gives a strong wind and heavy extreme rain over the region. Without assimilation, it is called control experiment in the right panel below. So it only simulate eastern part convections, not the northwestern part. And we assimilate the data into the numerical model, especially for the 21st May, 11:20 UTC. So we after there is a time lag, but we have seen that to distinguish convective cell generated after assimilating the radar data. So for the nowcasting purpose, for the operational procedure, these kinds of radar data is very important. So one thing, if we really able to archive those data for the longer time, all the seasons, like 10 consecutive years or more. So we can do some climate study. But after the closure of the SMRC or maybe others, or the non-functional of those radar, that these things are not available. Now we can see some reality of the other country, like for the Northern America, especially USA, 2002 to 2018, almost 20 years, you should say, daily average precipitation, which include all available next sites. That's one important study done by Saltykov and others. So within the study, they found that the region is very extreme precipitation occurred and which are less. So, and after that, they make a good rainfall precipitation database for the country. This is still used in other purposes, like compare with the satellite data or others, rain gauge data. If they install new instrument, they verify their data set and others by using this climatological defined data sets, which already been archived in their national department, NOAA. So that is one important things they already been done. But many of other countries not have these kinds of opportunities. I think that is the high time now we should start these things for the longer procedures. And you see from the another study in the top panel, it is from the NOAA. We can see all the radar stations over the regions. And second one is the 1996 to 2015 radar estimated mean annual precipitation over the regions. and below one is the Gauss estimated mean annual precipitation over the region. So there is a very significant distinguish, like central eastern region, there is a high precipitation area which is only defined through the radar data, but in the Gauss data it is not there. So these kinds of different findings are possible through the very high resolution data. And another things for one specific year or whole month, like January to December, frequency of precipitation echoes the rectify the frequency of reflectivity greater than or more 5 decibels Z. So that is the one frequency of precipitation equals the make a special plot. And second one is the convective echoes, who is the greater than or equal 45 decibel. And only for the hailstorm, this signified those greater than 60 decibel. So through these, who is at the hail, like central part is the more hail prone regions, and who is at the more convective echo prone region. There is the southern, southern and southeastern region. So these kinds of regional distinguish significance is also possible. And similar kinds of study already been done for the Germany. They used the radar network from 2001 to 2017, almost 17 years data set, and two special plot here. One is for the daily and another is for the hourly. And it is also they compare those things with their Gauss data, because in their some region there is a not very much rain Gauss coverage there. So they fulfill those things by using the radar radar reflectivity converted to the rainfall, and they make these kinds of climatological data set for their long-term use. Now, for the another extreme events, like in our southern coastal regions, every year, two different seasons. One is the pre-monsoon, mainly in April and May. Another is the October and November. These months are very much sensitive to the genesis of cyclone over the region. One is the pre-monsoon cyclone and the post-monsoon cyclone. But in the coastal, though there is a very good coverage of the radar, but sometimes it is not operational. Sometimes country transboundary, there is a not good coverage. Like Myanmar, there is only one radar, but it is mostly they're not archived. They're only operational during the extreme events. But in our country, like Chittagong radar, it well covers the region, many parts of the some parts of the northern Myanmar itself. So during the cyclone Mocha, we can see the reflectivity over the regions, and through the Doppler radar, we can see the very well cloud band over the regions. But if we are able to utilize those cloud reflectivity data to prepare a storm surge modeling, which is very much important, how would be the storm surge or water level increasing. But I'm still not sure these kinds of regional data coverage is there. Like the cyclone who is occurred just last week, cyclone Dana. So luckily, that is the maybe first time in history Odisha, it hit over the Odisha, but there is a zero death. That is actually well prepared disaster management. So in the Southern Asian is very much prominent to they face the disaster in various aspects, and they adapted with this continuously even the whole the year itself. So in regarding the storm surge model, they need the very good rainfall information. So because in the ocean there is no rainfall information or no buoy or others. So I think radar would be the one important solution for this, but it requires regional cooperation, real-time radar data sharing. So system format and other things are very much important. So it is really required for the climate monitoring itself. So we can do some good study for the 10 consecutive years tropical cyclone, pre-monsoon and post-monsoon. We can distinguish what are the rainfall behavior over the regions. So it is really one gap. So that's why this lecture, through the training lecture, we asked to the operational med agencies and other agencies who maintain the radar in a daily procedure. They should make a strong database in future need. So radar storage, radar metadata logging, minimum metadata, and standard terminology, it is very much required for the long-term systems. So in that regards, my recommendation, one is the data preservation. So initially, we should start with the very fine-tuning level 2 data, mainly reflectivity. Within reflectivity, radial wind is possible. That will be very good. And after that, we need to comprehensive metadata that needs the calibration history. Like if one radar outdated for after operational 10 years, so that history, that documentation is very much needed. But most of the radar station, they have three information in general. One is the position and another is the elevation. So these things are mostly available. But the main, another important is the radial wind and reflectivity information, which are not available or which are not sharing. And after that, standardized formats, there is many formats they usually mention. So we can do some of the formats which can be long-term, you can use. And after that, quality control for this consistent terminology, we need to introduce for the community. And interdisciplinary teams, it is not the only task of the meteorologist. There is a IT expert is required and some other people also needed. So that's why academia, government agencies and researchers, how it can be collaborated to for this, it is need to be think. And handling story data, inventory data, rescue, and analysis for long-term usability. Finally, international collaboration, as I always emphasize on this, an international portal is required to harmonize those collaboration in a proper way. Learn from the first efforts. What other countries already been done and what we learned, like SARC Meteorology Research Center 1 started through the severe thunderstorm observation regional modeling project. So it was a very successful project. That time radar data sharing was there, and those radar data already been used in academic purpose and research purpose. But these kinds of collaboration should continue for the at least not for 5 years. It should continue for at least 2-3 decades. So we can get a very good harmonized data. Finally, how SAMA can coordinate? SAMA can coordinate to inspire those agencies to archiving the data. So for this, we need to identify what are the challenges from their own organizations and challenges among the countries, and how it can be strengthened, especially for the collaboration. Now, almost in my final slide, so now I show some survey how we can do it for our community. So if it is one, it is just draft survey questionnaires. After that, I think this training we can make a good success. Like participants can learn many things from the training. But if the agencies come forward and they can started to archive their data by doing some baseline study to identify the limitations and other, that will be a one important milestone initiative of the training course itself. So just a minute, I would like to share the link. So here, it is a draft. Maybe some authority will decide further. Honorable President and Secretary Sir is there, so they will think of it. Initially, we can make the general information. Which institution is authority of this maintaining the radar? How many operational radars are there? And what kind of radar they are deployed for their network? That is the general information. After that, this section, we just focus on the radar data archiving. From which year they started their own radar data archive. If they start some year, they can mention. If not, they can mention the not yet. And then which are the following radar data, like reflectivity or which coordinate and rain rate, radial wind, etc. And therefore, are the following radar parameters fully saved in your archives, or if partially, they can mention. And metadata documentation, that is what metadata is available to accompany your radar data. That is the geographic position, height, scanning, whatever they can select what that apply. If many, they can select many. Is the format structure your archive content documented? If the different data have different kinds of format structure, so they can mention that it is the buffer tables or some variable information is or readme file is there, or if any documentation they can mention. Finally, data accessibility. Is the archive data, radar data accessible to researchers outside of the institute? Some institutions, they don't have these kinds of permission. Maybe for this, maybe MOU or other things is required. But I think it is really needed. So one initiative can be taken. Data retrieval management. How would you describe this process for retrieving 1 year of archive radar data? Execute a command line operation, access zip, how they do it? If they can make some zip format or some other format, or they need to, it's like some fast data. Australia and other countries, they usually maintain CD, disks, tabs, but nowadays those kinds of electronic devices are not almost outdated. So new things, cloud storage or other things can be popularized. Do you have any data backup for redundancy plan of radar data archives? If they have, they can mention. If not, they mention the not yet. Finally, for what purpose your radar primarily used? As I mentioned, most of the time they used it for the aviation purpose and the nowcasting purpose. Research purpose, very few. So if we know that they inspired them, please use it also for research and academic purpose. So the quality would be most improved in future. What are the main challenges you face? Maybe limited storage capacity they can face, lack of a standard format, insufficient metadata documentation, complexity of data archival, retrieval, privacy concerns. If it is there, you need to sort out what kinds of privacy then have, how it can be neutralized in future. Finally, limited funding resource, etc. So that is the one specific format I'd like to mention through the my presentation and my final slide. So what are the home message from these lectures? Ensuring high quality, well documented data is essential for effective climate research. Of course, adopting a standard format and protocols will enhance data longevity and accessibility for future researchers. Collaboration and interdisciplinary approach will be vital in advancing radar data capabilities to meet climate monitoring needs. So these are the some documentation and finally, thank you.
Thank you. Thank you very much, Dr. Mohan, for giving the opportunities, challenges, and how we can optimally utilize all the radar data and how to archive it and how to utilize for climate applications with examples. So it was a very thought-provoking and futuristic lecture. So thank you very much. And now I request all panelists to switch on their camera to have a photo session. Vijay. Vijay.
Kormakar sir is not there.
Okay, ready? 3, 2, 1.
Hello. Hello.
Sorry. Sir, we are taking a photo.
I couldn't hear.
Take again. Okay. Take photograph once again.
Sir, we are taking your photograph.
Okay. Actually, I was busy with some other. Thank you. Okay,
Thank
I'm
you, sir.
ready. Thank you.
Yeah. 3, 2, 1, go.
Yes, done.
Okay. Thank you.
Okay, thank you for taking the snap. And
Today,
I'm very much happy to be with you for a few minutes. And thanks to Dr. Mohan, who was my also colleague. So I'm very happy to see his lecture here. And today I wish to take leave from you right now because of some other reasons. Thank you very much. Thanks, Dr. Dash and Dr. Tyagi also. So thank you very much for today. Okay,
thank you,
next
sir.
Thank you.
time
Thank
I
you.
will try
Thank you,
to
sir,
attend
for
again.
your presence.
Thank you, Dr. Dash. Thank you.
Thank you.
Thank you,
Thank
sir.
you.
Thank you, sir,
To
for
everybody.
joining.
Happy Deepavali. Okay, bye.
So now I request Dr. Srigala to handle the QA session.
Sir, there are two questions. First one is what kind of storage software that can organize archiving the data on it? So he's asking about the software.
Thank you. I think it is a very important question. There is actually one important limitation also. So thematic real-time environment distributed data services, that is actually one known as the TSRE-DDS. So that is one procedure they usually mention, they usually recommended. But in addition, nowadays, usually most of the time, what is called hard drive and other procedure they mention. Some institute what they actually archive the data. But Amazon, Google Cloud, and IBM Cloud Service, those can be popularized in future. So it depends on the institute policy, what kind of procedure they will mention for the storage of their data sets. And of course, the company who from where they are purchasing the radar or they install the radar, that's also important. But Unidata management, that is called local data manager, and like NOAA, as per my knowledge, they use some specific weather and climate toolkits, that is WCT or something, for archiving their own data sets. So it depends actually, but it depends on institute. They can design their own data storage. But one example, when we archive the numerical model products, we not store all the products, like some basic variable, like one output is one like 10 GB. When we only rectify the some parameters, it reduce the size. It can be 100 megabyte or less than 1 GB, 500 megabyte. So that kind of procedure also can be maintained. So two things is important actually. What would be the time resolution after 10 minutes, 5 minutes, etc., and what parameter they will archive, and what will be the way they will archive their things. Thank you.
Okay, sir, next question. Why at present Bangladesh radar data is not publicly available, whereas the same was available a few years ago?
It is. Thank you. Yes, that is good concern that people are nowadays very much concerned to see the weather-related instrument and weather-related uh, parameters through the sophisticated instrument as well. So that is one thing. Earlier days, many radar was in functional. Like in our coastal region, there is a two radar. One is the central coastal region, Khepupara. Another is the southeastern Cox's Bazar. And through the another institute, Bangladesh Air Force Meteorological Directorate, they have one radar in the Joshua. It is the southwestern part. And central location, there is actually three radar. One is the Dhaka itself. Dhaka actually two, one through the Bangladesh Meteorological Department, another from the Bangladesh Air Force, and another is just a little bit north central, Gazipur. So due to non-functional of the many radars, like coastal radars nowadays not function state. And Dhaka radar itself, it is maybe not functioning. Mr. Shalom can tell more. And Gazipur radar, it is newly installed and they are just experimentally operational. So for his the person who asked the question, so Dhaka radar, Gazipur radar information is nowadays available in the Bangladesh Meteorological Department website. If he can click the radar part, he can see the rainfall reflectivity or rain rate. And if he check the Bangladesh Air Force Meteorological Directorate, this is BAF MET, Bangladesh Air Force Meteorological Directorate. So he can see the two radar information is available, and with two radar there is a mosaic information also available. So it is not available, it is not true, but earlier days there is a many more radars. Nowadays it is reduced. Maybe in coming future it will be increased again. Thank you for the nice question.
Sir, there are some more questions. Next one is, different country are using different manufacturers for radar. So how to keep it safe?
Yes, it is. That is actually concern. The thing is that, like in Bangladesh, most of the radar are provided through the Mitsubishi company of Japan. So the construction, the software, everything is designed by Japanese company itself. As per my knowledge, when I was in Kolkata radar training workshop in 2010, so I knew that that is from the Germany. So it means their manufacturer and their software is provided by them itself. So that is if it is from USA, like our Air Force radar, mostly from the USA. So their procedure is totally different than the our government agencies radar system itself. So the issue, that is the issue. Like German company using their own software, Japanese company using their own. Now in the 2010, 2010, not 2012 onward, 12 or 14 onwards, through the ISRO, there was an initiative to provide a radar to the Nepal. So it means ISRO has their own software and others. So harmonization needs dialogue. Harmonization needs some standard format. So WMO now doing some work on this, but I think national agencies need to come forward. And after, if once it is finalized, then they can tell to the company that please make some harmonized procedure to archive the data, to maintain the things in a well format. That is at least needed for two things. One is for the data format, and another is for the maintenance storage itself. Thank you.
Sir, next question, will frequency change radar data archival?
Will frequency change radar data? Yeah, it maybe because of the how they are maintaining it depends on that. In terms of like if they archive the reflectivity parameter, so and to maintain some software procedure, so there is a possibility of changes of frequency. I think there should be some standard procedure for this. I think Abhilash is the best person to mention something more about this.
Okay. Next question, what are the steps for quality control of radar data?
Actually, it depends on the what purpose. That is for the archival purpose. That is for the numerical, the assimilation purpose. That is for the some other issues. It depends on that. So, and operational agency uses their daily procedures. They first do one thing that is called the what is called. There is some different kinds of things like I forgot the word. Anyway, so they need to filter the clutters. That is not really the hydrometeor. So that is the actually first challenge. First, they need to quality control the clutters, like birds is there, building is there, aircraft is there. First, they need to distinguish the which are the real hydrometeor and which are not. So that quality control need to mention first. And other things like for assimilation, others the procedure is totally different. It depends on the purpose actually.
The next question, can you say something about iris radar, about software, and how can we use? Iris is
maybe I'm not the right person for to answer this one. It is Vaisala. The one mentioned it is from the Vaisala radar. Maybe we need to explore this.
Next question, Dr. Mohan, thank you for the lecture today. I'm heading to use radar data application. When possible, I want to use precipitation data for the purpose of finding magnitudinal impact of climate change on agriculture, soil moisture analysis. What is your perspective on it?
It is. I should give her a very good, very large thanks for it. It should be I think, one pioneer initiative. So, if really initiative can be taken, if there is any possibility to support or collaborate, I am very much eager to collaborate. I think that is required, because when I prepare my presentation, I tried my best to get some climate-related study over the regions. I did not get anything. So I think that is really required for our regions. And soil moisture and to apply for the climate change agriculture, that will be interesting study. Sure. Thank you.
Next question, is there a way to harmonize radar data archival in the format like in NetCDF or HDF?
It may be possible. Actually, NetCDF and HDF is the very popular format. So if once it is able to done, so it can be perfectly useful for the larger community. But I think there is some challenges, especially for the coordinate issues and others. So once it is done, I think it can be possible. But it should be start from the institute itself. After that, country to country collaboration is possible. Like in our country, two different companies are providing the radar. So first, we need to do some harmonization within the two companies through the national policy, national dialogue. After that, I think transboundary country can do it.
The next question, what are the limitations of this data sharing, like security breach and storage constraints?
Actually, nowadays you see many data available in different sources. Like alternatively, people are using GPM data, people are using satellite data. So if there is a strong regulations through the dialogue, so I think that kinds of constraints or data breaching can be overcome. Like med agencies data, if you want to get real time, maybe it is not available most of the time, but there is some other alternative sources. So people, those intelligent people can get it from the different way. And there is some other format like buffer data or the ZFS data are there. So I think even some radar data already been included in the ZFS data system itself. So we cannot stop to make some obligation regarding the data breach or security breach or storage constraint, etc. We should start first.
Okay, there were one more question. What about radar in ships? Are they available for weather and climate analysis?
Yeah, it's important things. I'm not sure about in the ship they are using any radar for some purpose or not. But to track the tornado, mobile data is there, right? So very developed country, especially maybe some of you can remember the person whose name is Tim Samara. He and his son most of the time busy with trace the tornado systems, and he was died and he was in these kinds of operational aspects. So, but in sheep, it is maybe there is some these kinds of option maybe there, some light radar system they can use. But security breach depends for what purpose they are using. Like in our country, military radar is there, right? So there is very confidential. They use it for their own purposes. So if there is something used for to detect the hydrometeor and other purpose, it cannot be, I think, a breach of any regulations, right? So it's matter for what purpose and what aspect they install the radar in a ship and they use it for that. I think it's important concern. But if they use the radar in a ship, that will be a good study. They can get much more information in the ocean atmosphere.
Srikala, you are muted. Please unmute. Srikala.
Okay.
Yeah.
Okay. So there are some more questions in YouTube. It is the use. What can we say about the use of radar in research? how we can excel the use of radars in research in climate research. Wanted to know whether.
I think it is already, that is actually main purpose to, first thing is that we should have, some countries, they don't have the long-term data, they use it for the 1 season, they use it for the 5 years, they use it for the 3 years. So whatever the concern is that first we need to store the data for some specific seasons, a specific year, at least for 1, 2, 3 years. So we can start on that. After that, we can inspire the authority, please store your data for longer time. So maybe we started with the small time step, but in future generation can do it for the longer time. So as one participant mentioned, she is interested to do some study climate change and agriculture by using soil moisture and also the radar data. So this kind of initiative is important to start the work. So first need the data and also the some objectives, research objectives or research question, and then they can do it. And of course, but my concern is very much related to the extreme events, like during the tornado, during the tropical cyclones. They really need some regional collaboration, because within the coastal countries, Myanmar, Bangladesh, India, Sri Lanka, Maldives, Pakistan. So there is almost 5 countries is there, but there is no real-time data sharing, but in very limited scale. So, but all countries have many sophisticated instruments. Some has the very good radar, Doppler radar, very potential radar, real-time instrument. But only what is called storm surge model operationally is available from the INCOIS itself. So if they get some more information from the regional country, their model will be much more improved. And this decision can be utilized for the Myanmar. This decision can be utilized for the Bangladesh, because coastal is a very different kinds of management. Still, there is many parties unfocused. So I think regional cooperation is very much needed for this sophisticated data.
Sir, the same person asked one more question. Any advice for countries like Ethiopia at beginning stage to enhance the use of radars in climate research and aviation purpose?
Aviation purpose is it is really uses, right? It is everyday using. And most of the international airport, they usually install radar for their decision-making procedure. Like earlier days, in the Nepal, Kathmandu, when there is no radar earlier days, so if there is any accident, so there is a concern that it is because of the meteorological issues or not. Like one Bangladeshi aircraft was destroyed in couple of years ago, and almost all passengers were died. So, and after the investigation, it is maybe because of the wind direction, maybe from the meteorological part, they mentioned 020. Maybe in the pilot or the person who is in the cockpit, he listened 002 or something. So it is opposite direction, right? 180 and 20. It should be northern or it is in the southern. So the aviation is the daily use, instantaneous use, and for climate, for use in the climate purpose. In the Ethiopia, this country, they have to archive their own data sets for at least for 1 season, so they can start with 1 season itself, and in the next year they will compare both season. If they archive for the whole year, so they can do it any kinds of study, seasonal study they can do, any extreme event study they can do, extreme rainfall event, and etc. So the first question is that they have the radar or not.
Okay. The last question is, what is the universal data format for archiving the as recommended by WMO or GCOs?
Thank you. Still, actually, it is in discussion phase. As per the report and study, they already mentioned 5 level of data. They recommended only for the level 2 data need to archive. But regarding the standard format, they is still, I think, in a discussion phase. I don't see any recent information regarding this. So I think WMO, GCOS, and another authorities there. So they need to discuss with the directly to the WMO. I think in future maybe they will recommend it. Maybe next year or something. They have some meeting, or after that they will recommend it some specific format. Before that, that dialogue need to be continued.
Okay, sir. That's all.
Thank you.
Okay.
Over to you.
Okay, thank you, Srigara, for nicely conducting the QA session. I am happy that Dr. Mohan, you got a lot of questions today. Last lecture, I have there were no questions. Maybe you might have taken the class very nicely. So what I
you,
want to
Mohan.
add, what I want to add is to this is that we have, because radar data, if you consider across, it's a heterogeneous data, so there is no frequency dependent, and the products are highly heterogeneous among frequencies. And to make it more standardized format, maybe at a level 2 we can do it. At a derived products level, maybe we can, so though with certain careful merging techniques we have to use by applying different type of weightage to different type of frequencies in deriving. Some of the radars are very good at deriving the rainfall amount, total accumulated rainfall. Some are good at estimating the cloud structure. Some are good at estimating the wind structures. All this depends. So there is no standard format, because once all this polar coordinate system, when we convert to Cartesian coordinate, we can store it in any format we wish to, and maybe being the standard format like NetCDF and HDF, even buffer is also widely used, because buffer is nowadays very good at sharing between the nations. So that way, when we make use of radar data in data assimilation, buffer is a very good format. So that also depends. It is actually the choice and convenience of sharing the data, storing the data, size of the data, all this matters when we. So there are a lot of scope also, because last question was regarding the application. So what I would say is that because in my last class was mostly discussing about the challenges and future means opportunities in radar field. So especially in the Doppler weather radar. So what I want to say is that the full potential of radar data is not yet realized, because there are a lot of scope. Even with a single polar profiler itself, there are a lot of scope is there still. So nobody have the gut to attempt all these things, because there are a lot of scope is there. The full potential of this Doppler weather radar data, high resolution data, maybe we can make the data at a resolution of 0.5 kilometer. That is normally very high resolution. So all this data making it in a standard format as a tile format across the regional level also is a very challenging job. So there are a lot of scope also is there, and at the same time there are a lot of challenges, and it is our duty to make use of this data efficiently and effectively, so and optimally. So that is what we all are here. Maybe this lecture series will put some light on this direction, and we will get at least 10 or 20 good radar application scientists. That is a very good achievement from this online course. So that is what I just want to add, and I request Somesh sir to have some remarks on.
Yeah. Well, thank you, Dr. Avilas. Before I summarize, I would like to request our advisory panel member from Myanmar, Dr. Calvin Wu, to say a few words, because I understand there are 5-6 Doppler radars in Myanmar, but is only one radar utilized presently? Could you please say something on that, Dr. Wu, please?
Hello, can you hear me?
Yes, very much.
Actually, we are running 3 radar, but some location not fully run by some constraint. For example, electricity like this. So we are running 3 radar. Product and image uploaded regularly in our website, the homepage of our website. So I think the sharing of the data under the standard format by the WMO. So we have a very long history in the GDS system, WMO GDS system. So we can see neighboring country also GDS message, radar observation message, but the data are discrete data, not continuous data. So we can find the radar observation for our neighboring area from the GDS, WMO GDS. This is my idea. So as you know, radar meteorology is very important in the today weather forecasting, especially for the life-saving early warning system or impact-based forecast system. So I noticed the series of 20 lecture very support and very helpful to participants to operate or operation and research activity and the assurance of the impact-based warning system or nowcasting. Then the second last lecture and the today lecture also the long-term archiving and storage to temporary and spatial changes long-term. So this is also very good idea. So this series of lecture are very excellent. And on behalf of Myanmar participants, I would like to acknowledge all the senior scientists and their institution, including secretary and president and other senior scientists or SAMAT to organize this kind of series of data lecture. And we hope next time, like this, very applicable, operational concept of the data or other training. Thank you very much.
Okay, thank you, Dr. Calvin, for your remarks. Well, with regard to the summary of Dr. Mohan's talk, it was quite interesting. And as I said, Dr. Mohan himself has worked for his part of his PhD thesis on the application of radar data for thunderstorm forecasting in Bangladesh. He has also published many papers, obviously, on this topic. But looking at the different kinds of questions, which the participants have asked, that definitely shows that there are many kinds of interest in the participants. Although I don't know whether they have really ever tried to use the radar data for their research or not, but maybe just for the curiosity, people have been asking, different type of questions. I mean, the questions like how to quality control the data. I mean, as simple as that. You have not heard the previous lecture. That means there was a lecture number 16, which was fully dedicated for quality control and processing of radar data by Dr. Amar Jyoti from NCMRW. And she gave a very, comprehensive answer to the quality control procedure. So that means the participant has not heard the lecture. There are questions like, general questions like, I have not attended the lectures after lecture number 12 because of some reason. So whether I can attend the test or not. And these kind of simple questions. The point is that, well, as per the policy earlier, we thought that there should be some minimum requirement of 75% attendance. But later on, we also discussed that anyway, if people are able to watch the recorded lectures available on the YouTube and they are ready to appear in the test, score good, then why not? Probably we may allow them, even if they have not achieved 75% attendance. So those kind of things are general in nature. Regarding the radar data archival, well, I'm not sure how many audience really, and presently there are 46 participants still present, but there were about 78 in the beginning. So how many of them are really from the Met departments or how many are there just students, I don't know. But as you know, normally most of the countries, the Met services have at least one radar. And before you think about, archiving the global radar data, try to use your own radar of your own country. You will find a lot of difficulties in that itself. But mostly people use the radar, Doppler radar data for making case studies, of the extreme, weather events like the severe thunderstorms or so on. So try to use, the data of your own country's radar. First of all, just see that how much difficulties are there and what are the different formats. Obviously, the formats can differ because of the manufacturers. But at the same time, there are certain things which are very, very common. Like every radar will measure reflectivity. That is for sure. Every Doppler radar will also measure the radial velocity. That is for sure. Every radar will also have a velocity, a spectrum width, etc. That is for sure. But how it is archived, that is a different thing. By the way, I mean, some of you may be knowing that the WMO also is trying to develop a common, radar data format. You might have heard about the NextRad, things like that. That's generally three types of radar data recommended format recommended by the WMO. One is the NextRad level 2, that is WSR 88D format. The other is the CF radial data format, and the third is the ODIM, that is the Opera data information model. So WMO is trying to develop, by consultations from different countries with different countries and also the manufacturers, to develop a common data format for archival of the radar data. Unlike the conventional observations, like say for example, wind speed, wind velocity, wind direction, okay, or temperature or humidity. I mean, there are standard formats, or the pilot balloon data, or the radiation data. There are standard formats already developed by WMO and used widely by all the WMO member countries. But certain data are still, I think, not well defined, and still the consensus is being made on that, or is still in the process for development. In fact, unlike the other conventional data like radiation, or the SINOP, or the temp, pilot, etc., radar data probably is not shared on the GTS unless, I mean, you have got a special fact. I don't think any country is sharing the radar data because there is no well-defined procedure still developed for that. And most of the countries, even inside one country itself, there can be so many types of radars manufacturers. But as I said in the beginning, the common data will be the same. So generally, we can say that we use the radar data for three purposes. One is to study, like case study of different thunderstorms or severe storms. Other is like a simulation of the radar data in the numerical model. And third is, of course, trying to generate the high quality merged rainfall with satellite rainfall observations, the ground-based rain gauge observations, and the high resolution radar derived rainfall. In fact, some of the countries are trying to make that, like NCMR development is also generating on a routine basis the merged data set based upon Doppler radars available in India, satellite derived radar rainfall data, as well as the rain gauge data. So those data are available, but not for a long time. They have recently started, but those things will go on. And in the course of time, of course, the past data probably also will be archived in a merged format. So those things will be used for a long-term data analysis or climate studies, especially for the rainfall. But generally, as I said, either it is used, the radar data is either used for the simulation purpose in the numerical model or for the study of the severe storms, or even for that matter, trying to retrieve the cloud microphysical parameters, which are generally not observed by other instruments, except satellites do sometimes retrieve, but then there are their own limitations. So with this short summary, I'd like to thank once again Dr. Mohan, because he has always a futuristic view for everything. Besides his own presentation, he will also make a future aspects of his talks and give some kind of a outline for the future steps. So thanks for giving all these things. Certainly, we need to develop common observation strategy, because and that depends on the countries. Again, own situations, like some countries have power problem, most countries have power problem, so they cannot operate the radar round the clock. India is operating the radar round the clock, and every 10 minutes there is a scan. But the same situation may not be in all the countries. Sometimes they operate the radar only when there is a system like cyclone, things like that. But otherwise, they don't operate it. Sometimes they just operate once in an hour. So it depends on countries, many limitations that they have. Therefore, developing a common scanning strategy is not so easy, and probably only WMO can suggest, after consultation with all the countries, that what should be the radar data archival procedure and at what frequency it should be archived, etc., etc. So thank you very much once again, Dr. Mohan, for very, very interesting talk, and the last talk of this series, probably not exactly last, but there is a talk also after this by the manufacturers of the radar. And so thank you once again, Dr. Mohan. On to you, Dr. Avilas.
Thank you, sir. So now I request AVM retired Professor Ajit Tyagi sir to have his remarks. Sir, Tyagi sir.
Mic is mute. Mic is mute. Yeah.
Am I audible now?
Yeah.
Yes, sir. Yes.
Hello?
Yes,
sir. You are
yeah.
Am I audible?
Yes.
No, I'm not able to. Yeah. Somesh, am I audible?
Yes. We can hear you.
Okay. So, well, it's a great finale of this 20 lecture series from Mohan's lecture and the question answer session, and the remarks by both Abhilash and Somesh with their rich experience in using the radars. So have been able to provide right directions to the students and participants. Mohan, we have to be, see, it is using radar data for climate is a very, very, I think, good idea, but has brought out their operational challenges of the storage of this data, long series, standardization, and availability. So, but we have to make this awareness, and I'll request you to write a popular article on this and maybe published in one of those journals like Vayumandal Current Science to create awareness about the need to have standardized climatology from the radar. And second is also to know from available countries how they are going. So it's a little bit of Sama can ask or do it. In India, I think Abhilash is a right person to inform about his radar data, and we can request IMD Dr. Gajendra Kumar gave us some introductory talk about radar data archival in India Med department. They are doing, I am sure, but more in details are required. And I'm sure for the research community, such data shouldn't be a problem to access. So it is from the operational single radar data to have a data of network radars or different type of radars is a challenge, but it is the right time to take up these, and the SAMA can be a good platform to make the people aware, create interest, and bring some of these agencies together. Thank you.
Thank you, sir. Thank you, sir. Thank you very much. So we are towards the end of this lectures, means formal academic sessions of this long lecture series, and maybe for the exams on 16th, we will be mostly questions will be covering up to this lecture. Next lecture will be delivered by industrial collaborators, from manufacturers, from Indian radar manufacturing section. So after that, there will be on 16th, we are conducting an online exam. Basically up to 20th. All these 20 lectures are available in a YouTube channel of Sama. Those who are, as Somesh sir rightly pointed out, there was a dedicated session on QC, quality control. So if I am sure that the person who asked that question might have not gone through this YouTube channel and lecture series. I again request all the participants to watch the previous lectures and appear for the exams, and wish you all the best. And we will meet on 9th for the industrial presentation. So I request Dr. Palomi to propose the formal vote of thanks.
Thank you, Abhilasha. And I'll quickly share my screen. Let me know if it's visible.
Yeah,
If-
visible. It's visible.
Esteemed guests, distinguished speaker, and respected colleagues, as we conclude the 20th lecture, 20th and the last lecture of the Radar Meteorology lecture series, it is my honor to extend the vote of thanks on behalf of the South Asian Meteorological Association and the Advanced Center for Atmospheric Radar Research and the Cochin University of Science and Technology, India. First, I express our gratitude to Professor Dr. Someshwar Das, Secretary of SAMA, for his vibrant welcome address and the end note that set the precedent for the lecture. We extend our heartfelt gratitude to AVM retired Professor Dr. Ajit Tyagi, sir, who is the President of SAMA, for your educational opening remarks and unwavering dedication to guiding the youth of our generation with your tireless efforts. Thank you, sir. We would also like to express our sincere commendation and gratitude to our eminent speaker for today, Dr. Mohan Kumar Das, sir, who is the director of NOAMI Bangladesh and also the joint secretary of SAMA, for his enlightening lecture on weather radar and climate, long-term radar data sets, their preservation and analysis. Along with this, we deeply appreciate Dr. Rohini L. Bhavar, Assistant Professor, SP Pune University, who is also an ECT member, SAMA, for the eloquent introduction conveyed by her for our guest speaker today. We are deeply appreciative of Dr. Shrikala PP, Assistant Professor at the Cochin University, for her efforts on moderating the question and answer session and making it a lively and productive discussion. Also, lastly, a big shout out and our heartfelt gratitude to Dr. Abhilash as Director of the ACARR, CUSAT, and the program convener for the Radar Meteorology series for overseeing the entire session and seamlessly orchestrating the Radar Meteorology lecture series throughout this past few months. Once again, thank you all present today for their active engagement and contribution, and those working on the sidelines for all these months for making this session a success. Thank you, everyone. And this is me, Poulami Chakravarti. Thank you.
Thank you,
so much.
Dr. Thank you, Dr. Paulami, for proposing the vote of thanks, and we will meet on 9th for the industrial presentation. See you then. Bye-bye. Thank you.
Thank you. Bye.